this video, we will discuss about the trigonometric Fourier series derivation. Before that, we need to understand a little bit about the Fourier series representation and a few orthogonal components of a sine wave. Let's first consider the orthogonal components of sine wave, that is sine m omega naught t and sine n omega naught t. These two components are orthogonal in the interval t naught comma t naught plus 2 pi by omega naught, t naught comma t naught plus capital T, and capital T is basically the time period which can be written using this formula 2 pi by omega naught, wherever the m and n are the integers. So if m and n are the integers, then the sine wave, like these two components, are always orthogonal in this particular interval. The orthogonal component sets can be written using like sine omega naught, sine 2 omega naught, sine 3 omega naught, and up to sine n omega naught. You can write the orthogonal component using these sets. But these are not the complete orthogonal components, because the cos wave is also there. So that is why you need to write the complete orthogonal component sets using this, like sine 0 omega naught t. This is also there because sine 0 is always 0, so that is why you can replace this if you want, but I just write for the sake of simplicity. You can replace sine 0 omega naught t. You can start from sine omega naught t and then sine 2 omega naught t and so on, and then cos 0 omega naught t, because cos 0 is 1, so that is why you write there cos 0 omega naught t, cos omega naught t, cos 2 omega naught t, and so on. So trigonometric Fourier series representation is an approximation of any signal with a complete set of orthogonal signals. Like for approximation of any signal with any other signal, we need coefficient of approximation, COA. Similarly, if you want to approximate the trigonometric Fourier series, you need the coefficient of approximation for each function in the set. In the above set, we can consider Bn coefficient of approximation for the odd functions, that is the sine wave, and An, that is the coefficient of approximation for the even function, which is the cos wave. Then the function can be represented as, because as I said, the cos 0 is always 1, so the coefficient of approximation for cos 0, it will be equals to A0. And the coefficient of approximation for cos 1 will be equals to A1, and the coefficient of approximation for cos 2 omega naught t will be equals to A2, plus so on. And for the odd components, the coefficient of approximation, sine 0 is 0, so that is why 0 multiplied by B0, the answer will be 0, so you don't need to write the that component over here. So that is why we start from B1. So B1 sine omega naught t and B2 sine 2 omega naught t, so on. And this also includes sine m omega naught t and sine n omega naught t. To make it more simple, you can write that function using this form equation. F of t is equals to A naught. So A naught is basically, you can say it is a DC component plus sum where the value of n varies from 1 to infinity, because for this 0 it is a DC component. And then you can have An cos n omega naught t plus Bn sine n omega naught t, where An is the coefficient of approximations for the even function and Bn is the coefficient of approximation for the odd function. And we need to know how can we draw these values. So then the derivation of the coefficient of approximation. The general formula of the coefficient of approximation for two given function, for example, we have this function f of 1 and we have another function f of 2. that we have already explained in the previous slide. For the case of, we have already described these two functions and how can we approximate the two functions, or how can we represent the first function in terms of the second functions. We need to know the coefficient of approximation. So this has been discussed in the previous lecture of the Fourier series representations. So let's suppose we have two functions, the function f of 1 and the function f of 2, and both are related with the coefficient of approximation c1 of 2, and the general formula to calculate the coefficient of approximation is given by this equation. So c1 of 2 is basically the ratio of that product divided by the integral of the square of the second function. So like you can say the integral of the first function multiplied by the second function divided by the integral of the square of the second components. So we have already given that function for the trigonometric series. F of t is equals to a naught plus summation where a n cos n omega naught plus b n sin n omega naught t, where if we consider the even function and the coefficient of approximation a n is denoted by c12, and we say cos n omega naught t is a function 2 and where f of t is function 1. So like we are basically representing using this equation, and then we can basically use this formula. So in order to calculate an, because we know the coefficient of approximation can be calculated using this formula. So similarly, in the same manner, we can say that to find the value of an, we will use this formula. So for this formula, we can say the integral whose limits start from t naught to t naught plus capital T. We have first function is f of t, we have second function cos n omega naught t and dt, divided by the integral of the square of the second function, the limit of the integral t naught to t naught plus capital T and cos square n omega naught t dt. So this is a even coefficient. We can also find the coefficient of approximation for the odd function. So in this case, we say that this is our first function and the coefficient of approximation c12 is bn in this case, and our second function is sin n omega naught t is the second function. And to find the value of bn, we use the same formula like the integral of the first function multiplied by the second function divided by the integral of the square of the second function. So this is the odd coefficient. So to find the value of a naught, again we use the same formula. So where f of t is the first function, and you know that you don't have the first function because the cos is 0, the cos value of cos 0 is 1, divided by the integral of the cos square of 0, and you know again cos the square of 1 is again 1 and cos 0 is again 1, so you only have the integral of first function multiplied by 1 divided by the integral of 1 dt. And you know the integral of 1, the answer is t, and if you insert the limit, then you will end up with capital T. You can take that out, 1 by t integral whose limits are t naught to t naught plus t, and you have only the function. So in this way you can calculate the value of a naught. Similarly, you can calculate the other values as well, because we know that cos square x is equals to 1 plus cos 2x divided by 2. So you can also write this equation in this format, that is 1 by 2 plus cos 2x by 2. So to find an, you can say that okay, the cos square n omega naught t, so you can use this trigonometric identity here in this case. And you know that the cos 2x by 2, if you take the integral of this function, the answer will always equals to 0. And if you take the integral of 1 by 2, which is a constant, and the integral of a constant is usually equals to t, and if you insert the limits, you will end up with t by 2, and then you can find the value of a n using these values in the previous equation. So you can say that the value of a n is equals to 2 by t integral whose limits start from t naught to t naught plus t f of t cos n omega naught t. And this is for the even coefficient. Similarly, you can do for the odd coefficient, because we know that sine square x is equals to 1 minus cos 2x by 2. So that is equals to 1 by 2 minus cos 2x by 2. And you know, if you take the integral of that particular cos wave, the answer will be equals to 0. And then if you take the integral of this constant 1 by 2, we have already derived that, so that is equals to t by 2. So you can use these two values in the previous equation, and then we can write the odd coefficient of our signal. So that is basically b by n is equals to 2 by t integral whose limit t naught to t naught plus capital T f of t sine n omega naught t dt. So this is for the odd coefficient.